Okay, Chapter 7 begins with a lesson on zero exponents and negative exponents. Your learning target is to simplify expressions with zero and negative exponents. You can set up your Cornell notepaper. This is lesson 7.1, and write in your essential question. And just like always, when you're ready to go, you can hit resume. So here's a definition for zero exponents and negative exponents. Now, it's not my favorite definition, but it is the definition that your book uses. And I'll start with zero exponents. Anytime you have an exponent of 0, the answer will always be 1. Notice that 4 raised to the 0 power is 1, and parentheses negative 3 raised to the 0 power is equal to 1, and any number raised to the 0 power always equals 1. Now I can take the time to show you how that's possible and why that's possible, but I'm not going to right now. Just for now, think of it as a definition. Anything raised to the 0 power equals 1. There's a couple of exceptions to that rule, and I'll show you that in the examples that are coming up. Negative exponents are even stranger. A negative exponent means the reciprocal, and you can see that by this definition. A to the negative n means 1 over a to the n. I'm going to show you a way to think of it that's slightly easier, at least it is to me. So here we go. First example that you should record in your notes, and we start with 2 to the negative third power. Here's how I approach negative exponents. When you have a negative exponent in a problem, you can always think of it as a fraction. So I'm going to rewrite 2 to the negative 3 over 1. Anytime you have a negative exponent, you can change that negative exponent to be positive by moving it. So this number, 2 to the negative third, is on the top of the fraction. I'm going to move it to the bottom and make it 2 and change the sign to be positive. Anytime you have a number with a negative exponent, you can move it from the top to the bottom, and that will change the sign of the exponent. And I know there's going to be some confusion, but go ahead and write the example down, and we'll clarify in class. So if I do that, what happens with the 1 on the bottom? Well, that just means 1 times 2 to the third power. And what about the top? What's left? Well, it's not 0. What you've done is left it empty, so you fill it with a 1 as a placeholder. So your answer is 1 over 2 to the third power. And 2 to the third power is 2 times 2 times 2, which is 8. Okay, so I'll come back and do another one to make sure you're clear on that, but let's move on. Here's an example of a zero exponent. And the definition of a zero exponent is anything raised to the 0 power is equal to 1. So negative 4.5 in parentheses raised to the 0 power is 1. What happens though if you have a number raised to the 0 power that's not in parentheses and includes a negative? Well, the way you approach that is to say what's being raised to the 0 power is just 7. And 7 raised to the 0 power is 1, and then you attach the negative symbol. So what's the difference? When you have something in parentheses that includes a negative, that's just 1 because everything is raised to the 0 power. When you have something that's not in parentheses, the only thing raised to the 0 power is the number itself, which equals 1, and then you tack the negative sign on. Again, if you're confused by these problems, that's why I'm teaching you ahead of time. Come to class and we'll do the work together and you can ask me questions. Okay, part D. Now you have a negative exponent. So to get rid of that negative exponent, I'm going to make this problem a fraction. The way you get rid of the negative exponent is to move the number that has the negative exponent from the top to the bottom. And when I do that, negative 6 to the negative second power becomes negative 6 to the positive second power. Notice the only thing that changes is the sign on the exponent, not the sign of the number. And if I move that number from the top to the bottom, what's left on top is 1. This bottom number is negative 6 to the second power. And what's being raised to the power of 2 is 6. 6 to the second power is 36. Still have the 1 on the top. Still have the negative. The answer is 1 over negative 36. And the last example, now I have a negative exponent, but instead of being on the top, it's on the bottom. But the same rule applies. Every time I have a negative exponent, I can move the number from the top to the bottom or from the bottom to the top. And when I do, I change the sign of the exponent. So if I move this 3 to the negative third up to the top, it becomes 3 to the positive third. And what's left on the bottom? Just 1. Well, anything over 1 is just the number itself. So really this is just 3 to the third. And 3 to the third is 3 times 3 times 3, which is 27. Okay, take a second and make sure that you've at least written down the examples so that if you do have questions when you come to class, we can start there and look at the examples together. Those are examples of negative exponents and zero exponents with numbers. But wait, it gets even more fun. You can also have zero and negative exponents on variables, as you can see in this example. So there's no way to simplify 5 a to the third b to the negative third c. There's nothing in this problem that can be added or multiplied because none of the letters are the same. There are no like terms. But there is one thing you can do to simplify this, and that is to notice that b has a negative exponent. So the way you simplify it is you make a fraction bar, and if I want to change this b to the negative third to make it b to the positive third, I just have to move it down to the bottom, and then it becomes b to the positive third. So your answer is 5 a to the third c on the top and b to the third on the bottom, and that's it. Okay, let's do another one. The reason I included this example is to show you that some people will get the negative on the coefficient mixed up with the negative on the variable. The exponent is the only thing that when it's negative allows you to move it. Let me say that differently. If a letter or a number has a negative exponent, that's when you move things from the top to the bottom. Not if it has a negative next to the coefficient or the number. So in this problem, d to the negative third is the only thing that has a negative exponent, so I'm going to take that and move it down and make it d to the positive third. So what's left is negative 2 on the top, d to the third on the bottom. Looks like that one got a little messed up. This should say 1 over y to the negative fourth. And in this problem, I have a variable that has a negative exponent, and it's on the bottom. So the only way I can change the sign of the variable or change the sign of the exponent on the variable is to move it, either from the bottom to the top or the top to the bottom. So I'm going to move this up to the top, and it becomes y to the positive fourth. What's left on the bottom? Just 1. What about this one? What happened to it? Well, I can write it in like this, 1 times y to the fourth. But really these 1's don't add anything to it. 1 y to the fourth is the same as y to the fourth, and over 1 is just the same as having a whole number, so that's my answer. Okay, another one got messed up. So in this last example, I've got several variables. First thing I'm going to do is take care of all the negative exponents by moving the variables below or above based on where they're at. So this s to the negative fourth, I can move down to the bottom and make it s to the positive fourth. Now the way you see me do it in this example with the arrows and circling is probably the same way you should do it on your paper. And once I've moved it, I'm just going to put a single line through it. That means I've taken care of it already. And this r to the negative 2, because it's a negative exponent, I can move up to the top and make it r to the positive 2. And now I'm going to put a single line through it to make sure I know that I've taken care of it. So what I have left is t to the third and r times r squared over s to the second power times s to the fourth power. And if you recall exponents, r times r to the second is r to the third on the top with the t to the third, and s squared times s to the fourth is s to the sixth. And that's it. And again, I'm going to repeat myself, but if you're having trouble understanding what I'm explaining, just make sure you have the examples written down, and then when you get to class tomorrow, we'll look at some of these examples and do some of the problems out of the assignment. Okay, example 3. The word evaluate means replace a letter with a value. So evaluate s, or evaluate this expression when s is 3 and t is negative 2 just means to substitute. So before you do any substituting though, if you have negative exponents or zero exponents, you want to take care of those first. So I'm going to rewrite this expression 4s to the negative 2 t to the third by moving the negative exponent so that it's below. So my new expression is 4 t to the third over s to the second. And now I can take the values s equals 3 and t equals negative 2, and I can put those in place of those letters. And remember, always replace a variable with a letter by putting it in parentheses. So 4 times t is negative 2 to the third power over s is 3 to the second power. Negative 2 to the third power means negative 2 times negative 2 times negative 2, which is negative 8. 4 times negative 8 over 3 squared is 9. So you get negative 32 over 9, and that's where you can stop. That's simplified. Here's another example. Same letters, same values for s and t. Take a second, push the pause button, and try this one by yourself. Okay, so if you did this by yourself, the first thing you should have done was notice that two of the variables, or both of the variables, have negative exponents, so I'm going to move them. I'm going to move the s up to the top and make it positive 2, and move the t down below and make it positive 3. So my new expression is 10 s squared over t to the third power. And now I can take the values for t and s and replace them in this expression. T is negative 2, and s is 3. Three squared is 9. 9 times 10 is 90. Negative 2 to the third power is negative 8. Now you could leave that as an improper fraction, except that it's an improper fraction that can be reduced. Both of these are divisible by 2. So a better answer is 45 over negative 4. Okay, this next problem is a story problem. Now don't get hung up on this word problem and all of the things that it represents. Just try to focus on what we're learning today, and that is zero exponents and negative exponents. So here we go. It just says a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1000 times 2 to the h. 1000 times 2 to the h is what you should write on your paper. This problem not only has zero exponents and negative exponents, but it's also getting you ready for exponential growth, which we're going to look at later in this chapter. H in this problem represents the number of hours. H is the number of hours after a scientist measures the population size. So it just asks you to evaluate when h is 0 and when h is negative 3. So I'm going to take this expression, 1000 times 2 to the h, and I'm going to evaluate it when h is 0 and when h is negative 3. So it's two different expressions. First when h is 0, and second when h is negative 3. Well, we just talked about what a zero power means. 2 to the 0 power, this part, equals 1. Anything raised to the 0 power is 1. 1000 times 1 is 1000. And we also just talked about what a negative exponent means. It means take that number, move it below, or change it from the top to the bottom and make the exponent positive. 2 to the third power is 8. 4 will divide evenly into 8 2 times, and 4 will divide evenly into 1000 250 times, and I can go even further, 125. And that's it. Now the last part of this problem says what does each, or what is the value of the expression represent in this situation? Well, if h equals 0, how many hours has it been since the scientist measured the first population size? 0. So h equals 0 means that's kind of the beginning point. In the second one, h equals negative 3. Well, how can you have negative 3 hours? What it really means is that's the population size 3 hours earlier. But again, don't get hung up on all the specifics on this word problem. What I really want you to see is how you can apply zero exponents and negative exponents to a real life problem. Well, that's it. Here's your assignment. When you come to class tomorrow, we will work on it. Again, I will clarify some of the questions that you have about negative and zero exponents. So come to class tomorrow with questions on your notes, and please don't come to class and say I don't get it. Come with specific questions. So take a few minutes to go back through the notes and look at each of these, and take the time to go, okay, well, I don't understand this one, or I don't understand this one, and put notes in your notes to help you remember where you got confused. Okay, we'll see you tomorrow.